Hello everyone. Today I'm going to discuss with you about the chapter chemical bonding, and this chapter is there for the first year first semester students and myself B Vijaya, Department of Chemistry, IPGDCW, Nampally, Hyderabad. So the chapter name consists of two words, chemical and bonding. What are the chemical bonding? What is the meaning of chemical bonding? So here we know that the universe is composed of the chemicals, the atoms, the elements, right? So and this matter means the matter is anything that which is having a mass and the volume which occupies the volume is called as a matter, and all the matter in the universe consists of the chemicals only, and through their bonding they are in the combined state, means not in the pure state. Only few elements exist in the nature as if pure states, as the pure states, like inert gas elements. They cannot mingle with any other elements. They cannot form the bond with any other element. Why? After a few while, we will discuss about them. And here, the bonding will be takes place between the two successive atoms of any elements. Any elements means here either the homogeneous species, means homo species means what? The within the same element also. So what is the element here we have to know again. The elements are, for example, we can see the periodic table, and in the periodic table we have the nearly 120 elements are there, and those are called as elements, the element. And these elements are consisted of some of the atoms, right? So these atoms, the atoms of the elements, and forms the bonds, and how they will form the bond again we will discuss in this chapter. So they will form the bonding between themselves and between the atoms of the other elements are also, and this is called as a chemical bonding. The bonding is the link between the any two successive atoms, and any two successive atoms of the same element or different element also. For example, the hydrogen always which is exist in the form of the H2 molecule. H2 molecule. Actually, the what is the element of the hydrogen? The hydrogen element is hydrogen as shown in the periodic table. This is shown in the periodic table, and this is called as a hydrogen element. And what is this hydrogen gas? The hydrogen gas, this is in the molecular formula, and this is the bond between the, this is the bond between the, means there is a bond between the two atoms of the same hydrogen element. This is the hydrogen atom and this is the hydrogen atom, and these are the atoms of the same element here. So similar way, the oxygen, this oxygen is a molecule, and this is the oxygen. How it is formed? The bonding between the two oxygen atoms, the two oxygen atoms of the element oxygen. Again, what is the element of this molecule here? The oxygen is a element here. And similarly, chlorine, chlorine. So chlorine, this is the element, and what is the molecular formula of the chlorine? And chlorine forms a chlorine gas. Chlorine is existing in the nature as a chlorine gas, not as a chlorine element. This chlorine is having a, means they forms always, they exist in the form of the dimer form. So it can form the bond within themselves. The chlorine atoms are the same similar atoms, and these are the atoms of the chlorine element only, and they are forming a bond within themselves. And also, for example, here one of the chlorine atom I am taking and one of the hydrogen I am taking, and it is also forming a bond between themselves, means here the bond is forming between the atoms of the two different elements. Chlorine is one element and hydrogen is differ than the chlorine element here. So two different elements, the atoms of the two different elements are involving in the bond formation. So the link between this chlorine and hydrogen here, and the link between the chlorine here, the link between the hydrogen and hydrogen here, and the link between the oxygen here. So these are called as a chemical bonding. There is a relation. The relationship is taking place between the any atoms, the successive atoms of the either same element or different elements are called as a chemical bonding. And this chemical bonding are of two types. One is the ionic bonding and second one is the covalent bonding. So what is ionic bonding and what is covalent bonding? Let us see now. And how the uh, why the chemical bonding will be takes place actually. So here in the periodic table, if we see, all the elements are having a either partially filled electronic configuration. So here the electronic configuration plays a very important role. And just uh, before this slide, we already discussed that the inert gas elements or zero group elements. These elements such as helium, neon, argon, krypton, xenon, radon, etc. These elements cannot form a bonds with any other atoms of the any other element. So why they are not forming is the reason behind that is these elements are having a fully filled electronic configuration. Like for example, I am taking neon, and neon, what is the atomic number of neon is, which is it, 10. The 10 is the atomic number of neon, and here if we write this atomic number in the form of the electrons in the orbitals, so it is a 1s2, 2s2, 2p6. So here the last electrons means the last orbital is the second orbital. This is a principal quantum number. Second orbital is the last orbital, the outermost orbital. And in this second orbital, how many electrons are there here? Total 8 electrons are there. Means the maximum number of the electrons we can fill the 2 electrons only in the S shell and 6 electrons we can fill in the P shell. So total in the second orbital, how many electrons we can fill? The 8 electrons we can fill. So here the neon is having a fully filled electronic configuration, and in this state which is having a which acquires a very low energy, less energy, and in this less energy state the neon is getting a stable configuration, means stability, it is getting a stability. So because it is a stable and it is not forming a bond with any other element. But if we take anything, for example, the next to neon in the periodic table is sodium. So sodium is having an atomic number 11, and which is a S block element, purely metal, and which is having a high electropositive strength. High electropositivity means what? It is having a tendency to lose one electron, means which ready to give up electron from its outermost orbital. So what is the electronic configuration of the sodium? Let us see now. Sodium is having a atomic number 11. That means the electronic configuration is 1s2, 2s2, P6 and 3s1. So the third orbital here n is equal to 3 and n is equal to 3, the s shell only one electron is present. One electron is present. And here the third orbital is the outermost orbital, and which is far away from the nucleus. Nucleus is somewhere here, and this is the there is a distance between the nucleus and the third last orbital. And this free electron, unpaired electron, is a free electron, and which is always roaming, means the very it is accelerating through the orbitals, because in the third orbital is having a s shells, p shells, empty p shells, and d shells also. So this one electron is always moving. It is taking some of the energy, it is utilizing some of the internal energy, and it is moving to the, means exciting to the next higher energy levels, and coming down. So like that it consumes the more energy actually. So in its states it is a unstable condition because of this one electron, because of this one unpaired electron in the outermost orbital. Whereas if you see here, these p6 electrons are completely packed electronic configuration. If you see the p shells, there the paired electrons are there. They are not having any mobility, like the spin motion and orbital motion is completely zero here. So these are the paired electrons, and because of that reason it is having a low energy and more stable electronic configuration, and that is the reason it is not forming a bond between the with the any other element but sodium, because of its one electron, and it has to get stabilized. It always stable try to get a stability. So that is the reason it always try to lose this one electron, to always try to lose this one electron to form a stable, to get a stable electronic configuration. So if the sodium loses this one of the electron, what happens? Let us see now here. So sodium is losing one of the electron and forming a sodium plus ion. And now let us see, the sodium atomic number is 11 here, and here also sodium ion is also having a atomic number 11. That means here the sodium is having a electronic configuration 1s2, 2s2, 2p6, 3s1. But here this one electron is lost by the sodium plus ion, means sodium atom here. So here what is the electronic configuration after losing this 3s1 electron? So it is having a 1s2, 2s2, p6, that means 2p6. So the second orbital is the n is equal to the second orbital is the outermost orbital of the sodium plus ion. Here the atomic number is not changing, please. Okay, atomic number is nothing but the number of protons. The number of protons are not changing here. So here the number of electrons is changing. That means here 11 electrons are there, and here 10 yeah, 10 electrons only there. One electron lost by the sodium atom to get a inert configuration like a neon. Inert configuration like a neon. And here in the sodium plus state, which is having a positive charge, and this positive ion is also a not stable one. It is always balanced with the negative charges, negative forces. So it readily combined with the either chloride ion or something else, something anion. So the bond between this type of the bond are attractions between the positive ion and the negative charged cloud and a positive charge ion is called as a ionic bonding. These are the attractions between the electrostatic attractions between the cation and the anion is called as a ionic bonding. Whereas covalent bonding, what is the covalent bonding? Let us see now. And first let us In a chemical bonding, atoms always want to achieve a noble gas configuration. So, as I till now I have given the explanation and why these elements are either losing the electrons or gaining the electrons. Actually, the transaction of the electrons is taking place. So, in the chemical bonding means in the nature, actually in the nature, no element is in the pure form except the noble gas element, and some of the noble gas elements are also xenon compounds are very active and they are forming a compounds with the oxygen, fluorine, halogens and oxyhalides are also they are forming. So these except this xenon and radon etc., this helium neon argon is almost inactive in state. That means almost they are unreactive states, because what is the reason behind this? The noble gas configuration, the fully filled configuration is called as the noble gas configuration, as neon is having a 8 electrons. So this is called as the octet rule, and this is first explained by the this octet rule is first explained by the scientist Lewis. And in the chemical bonding, atoms always want to achieve the noble gas configuration, that is the octet configuration, means fully filled electronic configuration. So let's first review ionic bonding. What is ionic bonding? And in ionic bonding, the electrons are lost or gained, resulting in the formation of ions in ionic compound. So here, as of now, we discussed already the sodium ion, sodium atom, and how it loses the one of the electrons from the its outermost orbital and forming into a the sodium plus ion. And similarly, the halogens also, all the halogens, fluorine, chlorine, bromine, iodine, etc. So all the halogens, they tend to they tend to gain one of the electron. Why? Because they are having a, here I will give you, they are having a uh, halogen. The halogen X represents the halogen, and this halogen is having a general electronic configuration ns2p5. ns2p5. So if we write this electrons in the orbitals, so ns2 is having a 2 electrons here, paired electrons, and in the p5, that means 3 shells are there in the p orbital. So here one electron, one electron, one electron, and here another. So 5 electrons are there, and this electron means it is a short of only one electron. If it is having a paired electron, see now how many electrons are there? 2 plus 5, total 7 electrons are there. Octet means, octet configuration means 8 electrons. So if it is having a one of the electron, if it is having a only one electron is short of getting a octet configuration here. So because of that reason, these halogens always strive to pull the electron from the any other atom of any other element. So they try to pull the one electron, they try to gain one electron always, and this nature is called as a electronegativity. 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 So as we've seen already in the case of sodium, sodium is try to losing the tendency to lose one electron always to get a stable electronic configuration. And this sodium is a purely metal S block element, and this is a purely metal, and the property of losing, the tendency to lose the electron is called as electropositive nature. And whereas here this X is nothing but here halogens we are taking, and halogens are the highly electronegative, and they always try to pull the electrons, means that they are having a tendency to gain the electrons or pull the electrons from the any other atom. So here metals are losing, they are having a tendency to lose an electrons, and here these halogens are the non-metals which are belongs to the p block, and they always try to gain the electrons. So here the ionic bonding always takes place between the metals and the non-metals, metals and the non-metals. Metals and the non-metals. So when the bond takes place between the metals and non-metals, these are called as a ionic bonding or ionic compound. So they are having a positive charge because of losing of the electron from their outermost orbital, and halogens are always gaining the electrons, always pulling the electrons from the any other atom, is called as a M plus, means M plus and X minus, the positive charge and negative charge. So the attraction between the positive charge and the negative charge is leads to form the ionic compound, and the bond, these attractions are called as ionic attractions or electrostatic attractions, um, are ionic compounds. Here, I am taking the example of the potassium and fluorine. See here, potassium again, which belongs to the metal, that means S block elements, and which is the next to the in the group, means alkali metals, next to the sodium atom. So here potassium is having a atomic number of 19, and 19, and which is having a 4s1 configuration. This 4s1 configuration means 3s2 3p6 already completely filled electronic configuration, and this is a one extra electron is present in the 4s fourth orbital and in the s shell. And here the fluorine is belongs to the non-metal, that means the halogen family, first element of the halogen family, and which is having a how many electrons, let us see now, total 7 electrons are there. So the two electrons from the two electrons from the 2s2, and these 5 electrons from the 2p5, 2p5. So let us see how the ionic compound will form. So this potassium is always tends to give the this extra one electron to the fluorine atom, and fluorine atom is eager to take, furious to take the this electron from the potassium, because to attain the octet configuration, stable electronic configuration. And now you see here the potassium is completely lost its electron, the electron of the potassium is lost, and fluorine is carried one of the electron. So now because of the losing of the potassium, losing of the electron from the outermost orbital of the potassium, and potassium is carrying a positive charge, and fluorine is getting the one of the extra electron in its orbital, in its outermost orbital. Now it become the outermost orbital is for the potassium is 3s2 p6. Here already means argon is there, means 10 electrons are there, and this fluorine is having a 2s2 2p6. Now fluoride ion is having electronic configuration 2s2 2p6, and potassium is having a 3s2 p6. That means here how many electrons are there? 8 electrons are there. So according to octet configuration, it is acquired a stable electronic configuration, and fluoride ion also it is acquired a stable electronic configuration by the addition of one of the electron from the potassium ion. So here the students must get the doubt, madam, we are adding the electron, but the addition of electron should be a positive, but we are showing with the negative sign. And by potassium, by losing the electron, it is getting a positive charge. So already I told you this positive charges, already we know that there is a nucleus, and nucleus consists of a protons and the neutrons, right? So neutrons doesn't carry any charge, neutrons doesn't carry any charge, and protons are nothing but these are the positive charges. Positive charges are the more highly energetic charge actually, and this the combination of proton and neutron will give the atomic mass, but here neutrons doesn't carry any charge and protons are having a charge. What is the charge protons are having? The positive charge protons are having. So what is the charge acquired by the nucleus now? Obviously the positive charge. The nucleus is having a positive charge, and this positively charged nucleus is, it is a unstable condition again, imbalanced again. So this positive charge is always try to attract the negative charges, and here the negative charges are nothing but the electrons. These are the electrons are the negative charges, and these charges are outside the nucleus, and these protons are inside the nucleus, and this proton number is nothing but the atomic number. Atomic number. So the positive charges, that means protons are nothing but the atomic number, and here, so what are the number of protons are there, what are the number of positive charges are there, and all these positive charges are balanced by the same number of the negative charges, that means the electrons. So here the electron number is always equal to the proton number in a neutral gaseous atom. Neutral gaseous atom, the proton number is always equal to a electron number. That means the electron number is also will be equal to the atomic number of the same element. So here we have the clarity that the nucleus is having a only one charge, that is a positive charge, and to balance this positive charges, the outside some other species are there, the negative charges are there, and this negative charges are balances the positive charges, right? So this clarity we got now, and let us take a one example uh, as a carbon. So carbon, the atomic number of the carbon is 6. What does it mean? So in a carbon atom, in a carbon nucleus, they are having a 6 protons are there. 6 protons are there, right? 6 protons are there, and 6 proton, because the positive charges proton number is equal to the atomic number, so atomic number of carbon is 6. That means 6 protons are there in the nucleus. In the nucleus 6 protons are there, and to balance this 6 protons, there are how many number of electrons we require here? So the same number of the electrons, that means the 6 electrons it requires to balance the 6 protons. 6 electrons are required to balance the 6 protons, right? Right? So 6 electrons are revolving in their fixed orbitals. Here elliptical orbitals will be there, and in those orbitals they are revolving around the nucleus in order to balance this positive 6 positive charges. But in case the carbon is if it loses one of the electron, if it loses one electron from its orbital, means it is losing, for example this electron it is losing, it is losing this electron. Now how many electrons are there? There are now 5 electrons are there, but how many positive charges are there now? There are the 6 positive charges are there. So this extra positive charge means by losing one of the electron from its orbital, outermost orbital. So how many electrons are there? 5 electrons only there, but how many protons are there? The atomic number is not changing because the atomic number is nothing but the proton number. Here the electron number is changed. So here how many electrons are there here? Only 5 electrons are there, but 6 protons are there. Means the 5 electrons are balancing the 5 protons only. 5 protons only, but one of the proton is single. Now, by losing this electron, one of the proton is not balanced one. That extra proton, and what is the charge of proton here? The positive charge, and this positive charge we are representing here. So the carbon is carrying a positive charge. Positive charge. That means by losing the one of the electron, the remaining 5 electrons are balancing the 5 protons, but extra 6th proton is not balanced. It is a single one. This proton, the charge of the proton is positive. That is the reason we are keeping a positive charge here. And if it gains the electron, that means carbon is having a 6 protons are there. So here I am keeping a protons 1, 2, 3, 4, 5, 6. Okay, and how many electrons? 6 electron. It is balanced by the 6 electrons. 6 electrons. If in case this carbon, so 6 protons are there, 6 positive charges are there. If in case this carbon uh, will gain one electron from the any other electropositive element than the carbon. So I am adding one of the electron to this carbon atomic orbital now. So actually in the carbon nucleus, how many protons are there? 6 protons only there. 6 protons are completely balanced by the 6 electrons here, right? 6 electrons here, 6 electrons here, and the electrons also I am writing 6 electrons. So the charge of electron is minus, negative charge, and here I am adding one more electron to this same atomic orbital of the carbon. But this electron is a single electron. There is no the positive charge here. There is no positive charge. This is a extra electron we have added. And what is the charge of this extra electron? That is a negative charge. So that is the reason we are writing a C minus carbon carbon anion we are writing, and this is a carbonium ion. C positive is the carbonium ion. So in this way they forms the cations as well as the anions. They forms the cations as well as anions, and that is the reason by losing the electrons they are carrying a positive charge. Positive charge is nothing but the proton. It represents the proton, and the minus charge is nothing but there are the sufficient electrons are there, means how many number of the protons will be there and the same number of the electrons are there, but also one extra electron is also there, one extra electron which is represents with the minus charge. This minus charge we are showing as a negative here. So by adding the electron, the elements get the negative charge. By gaining the electrons, they get the negative charge, and by losing the electrons, they get the positive charge, which represents the proton, and this negative is represents the extra electron. And the compound potassium fluoride formed now, and which consists of the K plus ions and the fluoride ions. That means potassium positive cations and the fluoride minus ions. And here, what is the bond is taking place between the potassium plus and the fluoride minus ions is this bond is called as the ionic bond, and this ionic bond is a purely attractions between the positive charge and the negative charge, and the positive charged species is called as the cation, and the negatively charged species is called as the anion. Next, and when this ionic bond is takes place is the electronegativity difference between the two atoms is more than 0.7. So if the electron negativity between the any two elements is more than 0.7, then the ionic bond will be takes place. The bond takes place between the two successive ions are called as the ionic bond, and this takes place when the electronegativity difference is between the two successive atoms is more than 0.7. And now let us switch to covalent bond. So what are the covalent bonds? In covalent bonding, the atoms again they wants to gain the octet configuration, means noble gas configuration, fully filled electronic configuration. They want to become a stable configuration, and they want to achieve a very low energy levels, but rather than losing the electrons or gaining the electrons, and some of the atoms now share the an electron pairs. So to form a bond, compulsory each and every atom of any element must require a one unpaired electron. So the two successive atoms, the sharing of the electrons taking place between the two successive atoms of a same element or different elements are called as a covalent bond. Here the mutual sharing will be takes place, and how, let us see now. So the shared electron pair is called as a bonding pair, bonding electron pair. And the example I am taking here, the chlorine gas, and chlorine forms a dimer. It is always exist in the dimer form as a chlorine gas. It is a green colored gas, and there is a almost all the non-metal species are having it, or otherwise the electronegativity difference between the two successive atoms are having a less than 0.7 or 0, which is equal to 0, is leads to formation of the covalent bonding here. Means the electronegativity between the each chlorine here, for example I am writing a chlorine here and one more chlorine. So these chlorines are the similar atoms, right? Similar atoms, and each chlorine atom is having a 7 electrons and 7 electrons, right? So 7 electrons, and electronegativity of this chlorine is having some 3.5, and the electronegativity of this chlorine is also having a 3.5. So the difference between the 3.5 and the 3.5, that is nothing but the difference, the electronegativity difference between these two chlorines are electronegativity difference is 0. So whenever any atoms of the elements are having a the uh, uh, electronegativity difference is 0, so then the covalent bonding will be takes place, and when there the mutual sharing of the electrons will be takes place. So here I am taking the example of chlorine and how the bond will be takes place between the two successive chlorine atoms. Let us see now. So uh, this is the electronic configuration, and each chlorine is having the same electronic configuration. Mm, that means each chlorine is having a same electronic configuration. Uh, that is a 3s2p5. So I'm writing only outermost orbital configuration. Actually, the full electronic configuration is 1s2, 2s2p6, and 3s2 3p5. So this is the complete electronic configuration of this chlorine as well as the this chlorine. And here the 3s2, this is the 3s2 electrons, 3s2 electrons, and this is the 3p5. 5 electrons are there, and here in one orbital of the p orbital it is a paired electron, and these are also paired electrons, and this is having a ability to form a bond because this is an unpaired electron. And similarly this chlorine is also having the same electronic configuration. This is the 3s2 electrons, and this is the 3px2, that means paired electrons, and py2 electrons, and in the pz only one electron is there. In the pz only one electron is there. So this is the electronic configuration of chlorine atom. So two paired electrons, two paired electron, one unpaired electron. This is the px orbital, two electrons are there. Py orbitals, two electrons are there, and the pz orbital, one electron is there. So this is the electronic configuration of chlorine atom, and each chlorine atom is having a short of one electron to get a octet configuration. Octet means what? How many electrons? 8 electrons. So if it is having a 8 electrons in the outermost orbital, so it will be considered as a stable configuration, and it is a fully filled electronic configuration. So that gives a stability and less energy it can acquire. So here the two chlorine atoms are trying to achieve an octet, and neither atom will give up an electron. Means here the two chlorine atoms are there, uh, they are having a equal strengths, both are having the same electronegativity difference. So among this none of the chlorine atom is try to give the electron, try to lose the electron here. So what happens here, the mutual sharing will be takes place here in order to get a octet configuration. So like this. Now this chlorine atom is having a 8 electrons, that means octet configuration it is achieved, and this chlorine atom is also having a 8 electrons, that means 8 electrons it got. So the octet is achieved by each atom of the chlorine by by mutual sharing the electron pair in the middle. So here the octet configuration of this chlorine and the octet configuration of this chlorine is forming a bond between the very stable bond between two atoms, two successive atoms, by mutual sharing of the electrons, and this is called as a bonding pair electrons, and which is a single bonding pair, so which is called as a single bond, and which represents with a dash symbol or hyphen symbol between the two successive chlorine atoms. So this will become a chlorine molecule now, chlorine gas Cl2, which is written as a Cl2 molecule. And now let us see one more example of oxygen. One more example of oxygen. Oxygen is also one of the diatomic molecule. This oxygen is also forms the dimer form only, which exists in the dimer form only. So why, let us see now. So the oxygen is having the electronic configuration of oxygen is 8, right? The electronic configuration of oxygen is 8, means atomic number of oxygen is 8, sorry. So 1s2, 2s2, uh, 2p4, right? So 2s2, 2p4. This is the electronic configuration of each oxygen, and similarly this oxygen atom is also having the same electronic configuration, 2s2, 2p4. So here if we write in this electrons, sorry, yeah, if we write this electrons in the orbital, this is a 2s2 orbital, and 2p4, 1 1 1. Always remember, we need to fill the electrons one by one only. So sorry, there is no one electron here. Yeah, 2p4. This is wrong. This is wrong. I'm unable to see this. So here 1 1 1, and here 2 electrons and 2 unpaired electrons are there. So in this way, and this is the one single electron, this is the single electron, this is the 2 as 2 electrons, and here 2p x 2 electrons, py 1 electron, pz 1 electron. Similarly this oxygen also. So now these unpaired electrons, which are having a which are short of 2 electrons to the octet configuration. So each atom has 2 unpaired electrons, and they will share these 2 electrons. And here we have to remember is oxygen is also more electronegative atom, very highly electronegative atom, and they will not try to lose any electrons. So they will not give up any electrons here. So better they will share these electrons only, both mutual sharing. And after the mutual sharing of the electrons, here this oxygen, both oxygen atoms are getting a completely 8 electrons here, and here they are sharing a 2 electrons. Since they are sharing a 2 electrons, because of that reason this is a one bond pair and this is another bond pair, 2 bond pairs they are sharing, and here 6 valency electrons plus 2 electrons are shared electrons. So it is completely a full octet it is formed, and this oxygen is also having a full octet. And how many bond pairs are there here? 2 bond pairs are there. This is one bond pair and this is another bond pair, and making a double bond here. And this double bond will be represented with the this symbol now. Just like a, it looks like a equal symbol. So, oxygen atoms, by mutual sharing of the 2 electrons, they are forming a double bond, and this will become a oxygen molecule.